Hello, my name is Laura Gortana, and this is my Calculus and Vectors CCT. Today we'll be taking a look into the McGraw Hill Ryerson Calculus and Vectors 12 textbook to answer an optimization question. The question we'll be looking at is on page 207, number 17. Number 17 states that in a certain region, the number of bushels of corn per acre B is given by the function Bn equals negative 0.1 n squared plus 10n, where n represents the number of seeds in thousands planted per acre. We will be starting off with 17a. 17a asks what number of seeds per acre yields the maximum number of bushels of corn. To start off, we will be taking the derivative of the equation and setting it equal to 0 to solve for n. You take the derivative because it gives you the slope of the tangent, where any value of x will give you the slope of the line. We are setting it equal to 0 because your maximum and minimum points is where the slope is equal to 0 because they are turning points. So you start off with your original equation, Bn is equal to negative 0.1 n squared plus 10n. To take the derivative of this function, you will be using the power rule. The power rule is when you bring down the exponent, leaving your equation to the power of your original exponent subtract 1. So with your equation, you will bring down the 2. Now you simplify the equation. After simplifying, the derivative of our function should be b prime n is equal to negative 0.2n plus 10. Now that we have taken the derivative, we will be setting it equal to 0 to solve for n. You first bring over the plus 10 to the other side, making it negative 10 is equal to negative 0.2n. Then you divide both sides by negative 0.2, leaving us with n is equal to 50. Since n represents the number of seeds in thousands, our actual amount of seeds is 50 times 1,000, which is 50,000 seeds. Therefore, the maximum number of seeds per acre is 50,000 seeds. If you wanted to know the maximum number of bushels, all you would need to do is plug your value of n back into your original equation. Since our original equation was Bn is equal to negative 0.1 n squared plus 10n, you would plug in 50 since it was the value of n into your original for every n value. Then you would end up with B50 is equal to negative 0.1 times 50 squared plus 10 times 50. Going to the rules of BEDMAS, you would first take the exponent 50 squared, then multiply the answer by negative 0.1, then add your value of 10 times 50, which should give you an answer of 250. Therefore, the maximum number of bushels of corn is 250. Now that we have answered 17a, let's move on to 17b. 17b asks if corn sells for $3 a bushel and costs $2 for every 1,000 seeds, find the optimal number of seeds to be planted per acre. To solve this equation, you need to use a profit equation. Profit is equal to the revenue equation subtract the cost equation. Let's start off by finding our revenue equation. To find revenue, it's price times number of unit. Our price is $3 per bushel, and our number unit is given to us in our original equation, negative 0.1 n squared plus 10n. So now that we have both, we multiply them together, which we get negative 0.1 n squared plus 10n, all multiplied by 3. The next step would be to FOIL in the 3, which would give us our final revenue equation, which is negative 0.3 n squared plus 30n. Next, we need to find our cost equation. To find the cost equation, it is cost per unit times number of units. Our price is $2 for every 1,000 seeds, and our number unit is n, since n represents seeds in thousands. Therefore, our cost equation is 2n. Now that we have both our revenue and cost equations, we can find our profit equation, which is revenue minus cost. After you plug in your revenue and cost equations, simplify the equation to get your profit equation, which is negative 0.3 n squared plus 28n. Now that we have our profit equations, we can solve for the optimal number of seeds to be planted per acre. To find the optimal number, it is the same process as 17a. You are going to take the derivative of your profit equation, then set it equal to 0 and solve for n. Let's start by taking the derivative. Once again, we will be using the power rule to derive the equation. Start by bringing down the 2 and multiplying it in. For the second value, plus 28n, the power is 1, and 1 subtract 1 is equal to 0, and anything to the power of 0 is equal to 1, which is why you drop the n, leaving it as plus 28. In the end, the derivative of Pn is equal to negative 0.3n squared plus 28n should equal P prime n is equal to negative 0.6n plus 28. Now that we have the derivative, we set the equation equal to 0 and solve for n. First, you bring over the plus 28, making it negative 28 is equal to negative 0.6n. Then you divide both sides by negative 0.6, leaving us with a value of 46.667 is equal to n. Since n is represented in thousands, the actual amount of seeds is 46.667 times 1,000, which is equal to 46,667 seeds. Therefore, the optimal number of seeds to be planted per acre is 46,667 seeds. So we have now completed the question. Hopefully I have helped you further understand optimization questions, and thank you for listening in on my Math CCT. Bye!